Uno.
Bueno, muy buenas tardes. Muy buenas tardes a quienes están aquí en el auditorio y a quienes nos ven a través del sistema de streaming. Es un placer para la Universidad de AFID poder contar con la presencia de John y Spencer, quienes han acompañado los cursos de Mintic durante ya varias semanas. Y obviamente para todos quienes nos estén escuchando en el sistema de streaming y viéndonos, ojalá puedan encontrar no solo en la charla de hoy, sino en las oportunidades que nos brinda la Universidad de AFID y la Escuela de Ingeniería en aliados como el Ministerio para poder llevar un mensaje más amplio y poder difundir la importancia de la ciencia de los datos y de las analíticas en el entorno de hoy. Así que sin más espera, agradeciendo al profesor Francisco Correa, quien es la persona que nos empuja y nos sigue animando a que estas cosas sucedan. Spencer, welcome. John, as well. And the floor is yours.
Gracias. Okay, thank you. Can we get this to broadcast, Miguel? How can we get that to go? For anyone watching, we're setting this up now. Should be 1 minute. You don't need a clicker. Yeah, just Okay, bueno. Okay, gracias. Gracias. Okay, thank you for waiting, everyone. Thank you all for being here. Thank you, Francisco Correa, for setting this up. It's a real pleasure for Spencer and I to be here at AFIT. AFIT has been an incredible host to us over the past 9 weeks as we've run our Data Science for All program. We've been in Bogota, Cali, Barranquilla, and Medellin, and AFIT has been my favorite place, so thank you for having us. Today I'm going to walk through what's titled A Look at Data Science, Present and Future. I'm going to focus on this concept that we're building right now with the Japanese investment fund SoftBank and with Mintic, building out a Colombian ecosystem of data science and AI talent to drive forward in Latin America and build the future of Latin American talent. Spencer will look at some kind of interesting challenges and questions that we've been exploring in class to kind of give you a sense of what we're learning. So, without further ado, I want to walk through these 3 things. This is a presentation where I walk through about 25 slides, but in reality, there are really 3 big concepts that I want to leave you here with today. So the first will be looking at the big picture. What is data science today? Why is it important? Why is it big? Why is it the future? The second is the opportunity in Colombia. How does Colombia fit into this global AI ecosystem? And the third is why DS for A matters. So why is data science for all an important component of Colombia's future here? So keeping those 3 things in mind, we're going to start with the big picture. I don't know why that fade was like that, but okay. You're not going to recognize this, but this is an interesting thought experiment that I want to begin with, okay? And I thought of this when I was actually on the airplane last night coming here. My company, Correlation One, we go around English-speaking universities. We've been to over 500, and we've tested over 50,000 data scientists to see how skilled they are. Not what is your degree, not where are you from, not who have you worked for, but how good are you? And what's fascinating about our study of a huge sample size of 50,000 is that while you see big names here, these are American universities, Harvard, Princeton, Cambridge in the United Kingdom. As you walk through and look at master students and PhD students, an interesting pattern emerged, which is that it's not just the big names as the places that you find the best data scientists, the best data talent in the world. For example, Purdue is the top. This is a university in the United States that's quite small. You don't hear about it as much. Technically very good, but not as famous as something like Harvard. Baruch College is a small university in New York, yet they have amazing data scientists at the master's level. Amazing. Best companies, best organizations in the world will hire from these places, but why? Well, one truth that we found is that high quality data talent is evenly distributed throughout the United States, and we think throughout the world. It is not confined to any one area, any one population, any one ethnic group, or gender, or anything. It is spread out. This is from our Future of Data Talent report. I'll send it to you. I'm going to provide my email if you want to look at it. So then thinking through, again, I don't know why the transition is there, but this matters because AI will be the biggest economic force in the 21st century. We're incredibly confident saying that because according to PricewaterhouseCoopers, it's a $15.7 trillion impact on the global economy. That's bigger than the current economies of China and India today. And that's only in 10 years, okay, by 2030. And to give you a sense of how spread out this is, less than a third of that market is in North America and Europe. So Latin America stands to gain from this, Asia stands to gain from this, Africa stands to gain from this. Pockets of talent will emerge everywhere. It's not just going to happen in one or two places. And the next sort of jump in this logical summary here is that countries have to develop AI talent locally. You cannot outsource talent because the things you use AI for are highly specialized. Data science is, after all, a science. It has to be extremely technical. When we talk to people at Colombian companies like Rappi or Ecopetrol, they're not going to hire data scientists in Texas or New York because those data scientists will not click at the detailed level with the problems that they have to solve. So instead, they have to hire from here. And that drives our program, DS4A. So a little bit about Correlation 1 before I jump into DS4A. We help some of the best companies in the world find out who to hire, how to train, and how to assess people in AI and data science. We work with top quantitative hedge funds like Citadel and Two Sigma, major tech companies like Lyft, big banks like JP Morgan. They come to us because they want the absolute best, not a lot of mediocre people. They want a very small band of very, very good people, and that's what we help them do. We've worked, as this shows, in over 6 countries around the world. EFIT is our first partner in Latin America. We're extremely proud to be here with you guys. We're also starting a partnership with Universidad de los Andes. And we work across languages and employ some of the best people in the world to design our training and assessment programs. So now thinking about the opportunity in Colombia, with that as the kind of baseline, why does it matter? What are we trying to build in Colombia? This starts with a pretty ambitious goal set by the Ministry of Education here in Colombia. And one of the things that I've really loved about working with Mintique and with the Colombian government is that you guys think big. This government that you have right now thinks big. They don't work on long timelines and vague deliverables. They want big change to happen fast. Their idea is to have Colombia be the most educated populace in Latin America by 2025 by working with recognized universities like Andes and EFIT, and by engaging a student population that's fairly large. In higher education in Colombia, there are over 2 million people. This is a big population we can start working with. And the essential thing we have to do is bridge this gap between STEM education and applicable skills. Regardless of what you're studying in university, you have probably run into this issue of the concepts you learn in class are very different than the work that you actually do after you graduate. In this program, we want to emphasize job readiness. So teaching skills that you can employ on the first day in the job that you're going to do after school. So like I said, job readiness, this is the key. How we've designed DS4A so far has been a 10-week program, so it's fairly brief. We teach practical skills using some of the best teachers in the world to teach you. And we customize the curriculum to what Colombian companies are looking for when they hire data scientists. And the point of this is really simple. We want to train great people to do things practically to make a big impact. So this is DS4A. And I'm going to start with a little video here of what this program has been like so far.
To do AI, you need talent, local talent, and this is exactly what our program delivers in a whole new way, local AI capability. We are thrilled at Correlation One to partner with Mintique and the government of Colombia to bring this program to Latin America for the first time.
Va a ser la red que va a jalonar de verdad la cuarta revolución industrial en el país de aquí en adelante. Ustedes van a ser los primeros en liderar todo lo que es un proceso de cambio a nivel de todo el país.
Yo soy ingeniero en electrónica y trabajo en medición de palas.
Vengo de una empresa, es una startup, se llama EnVIVO y estamos orientándonos hacia la transformación digital.
Yo soy del Ejército Nacional de Colombia, soy suboficial, cabo primero del Ejército.
Actualmente estoy trabajando como desarrolladora de software en una empresa que se llama Livebots.
Y soy profesor de estadística e investigador de la Universidad Jorge Tadeo Lozano.
Mi nombre es Mónica Zapata, yo soy de Medellín y estoy encantada de estar en Data Science for All.
Profesor como Natesh que viene de Harvard es casi un sueño.
Todo haya sido con hands-on y también al estilo Harvard, ¿no? Basándose en casos y desarrollando casos, buscando la aplicación.
Te pongan a pensar y hacerte las preguntas correctas. Motivarte a pensar sobre lo que estás haciendo y no simplemente hacer las cosas por hacer.
O sea, me parece que esto le hacía falta al país porque digamos que uno no encuentra como mecanismos para acceder fácilmente a un conocimiento tan valioso y de manera tan práctica. Miles de cursos hay regados a través de internet, pero siempre es importante contar con la asesoría de expertos en el campo.
Mi parte favorita ha sido el coworking. Hemos estado trabajando precisamente en un espacio bastante bueno, conociendo a personas de diferentes contextos.
El curso está muy bien diseñado, uno se siente muy bien tratado, eso es muy bonito. Sobre todo que dice uno, Dios mío, esto es gratis, y encima de todo parece que yo lo hubiera pagado.
Desafortunadamente, no solo en Colombia, pero sí, en general a nivel global, existe un déficit en cuanto a la formación formal que las personas pueden obtener en temas de data science. Entonces, para nosotros, encontrar esto en donde ya podemos encontrar como algunos programas que se enseñan esos skill sets que son los que estamos buscando, que no los encontramos en ninguna digamos, otra.
El efecto es que pueden volver más competitivas las empresas en Colombia.
Actualmente la industria del petróleo genera muchos datos a nivel de sensores y básicamente esos datos terminan siendo historia, no estamos haciendo nada con ellos.
Podemos predecir dónde hay una gran concentración de crímenes para ciertos tipos.
La metodología que se ha empleado acá realmente me ha parecido demasiado interesante porque todo es enfocado a un contexto de negocio, a un problema del negocio y a un contexto analítico.
Si yo hago un cambio en la cobertura o si hay un problema de deforestación en una cuenca hidrográfica y yo no hago nada al respecto, pues voy a ver que mi recurso hídrico se va a ir reduciendo a través del tiempo y yo necesito entonces tomar una decisión.
Tener el contacto directo con el profesor Natesh y la manera como ha desarrollado la clase me ha dado muchas ideas para cambiar mi práctica en docencia.
Mi sueño es ser un profesor pionero acá en el país en ciencia de datos. Creo que incluso me atrevería a decir que soy pionero, soy el único quizá militar aquí. Y la oportunidad de entregar lo que yo estoy aprendiendo aquí a todos mis compañeros, pues lo considero pues relevante.
Me encantaría de hecho que las niñas se emocionaran más por la ciencia de datos, que no les dé miedo, de hecho, lanzarse al ruedo. Para mí también es un tema nuevo, pero ha sido extremadamente apasionante y ha sido un viaje súper maravilloso y se lo recomiendo totalmente.
Un acierto en el sentido de crear un ecosistema. El ecosistema es un órgano vivo de cientos y cientos de personas que están en capacidad de transformar el país. Entonces, esa capacidad de traer 300 personas y proyectar miles de personas que estén funcionando como ecosistema es un acierto gigantesco.
Que no es que tocaba hacerlo por X o Y motivos, sino porque es que el país necesita el talento hoy, lo necesita ya, no podemos esperar.
Okay. So that's a little introduction to the program itself. Like I said, we're not done yet, but we made that about 7 weeks into the program. We have really one full week left. So how do we get here? This is I think the most fun part of thinking this through. How do you kind of put this thing together? What elements come into it? And what are the effects that you really don't see from a video like this or from the outside? Starting it off, in July, the government came to us with SoftBank and said, we want to evaluate talent, data science talent, and through a meritocratic system, through a system where we judge people based on their skills, what they can do, we'll bring them into the program. And we thought, okay, maybe we'll get a couple hundred people to apply, and we'll see how big of a program we can get. Well, when we launched this was in September, on the first day, after the second day, we had 1,000 applicants in Colombia. Within the first week, we had 10,000 applicants. And then we did a technical exam, Correlation 1.
Talent Stat Assessment is the first of its kind to scientifically identify elite investment talent. Currently, there is no objective method for identifying investment.
Someone interrupted me. Okay. I'm sorry about that, guys. Technical difficulty today. Okay. Then 6,000 people took our, 6,000 people took our technical exam. And this was very difficult to take because there was a 1-hour window on a Sunday where you had to take it. And we were amazed that 6,000 Colombians wanted to take this exam. And the scores were, I'm going to go into a little bit of detail. The scores were incredible. They were incredibly strong, much stronger than I think we anticipated, giving us the impetus to think this is a potential huge impact in Colombia. These scores, the baseline, the curve of the scores is matching up what we're seeing in some of the best talent markets in the world. From there, with Mintique, we selected about 300 participants for this program. And here's kind of the breakdown of how who applied and what they look like. So the basic takeaway here is that Colombian applicants are incredibly skilled and incredibly diverse. So obviously Medellin and Bogota are more than half of the applicants. You had a big concentration of private sector applicants as well, though there were plenty from the public sector too. Female breakdown was about 22-23% compared to men. And they came from industries across the map. So arts and entertainment, transportation, government, finance, etc. You don't have to be just an engineer to do this program because we think of data science as a horizontal rather than a vertical. It applies across industries. So from there, we selected our people. And this is a photograph on the left of Bogota. This is on the right, Medellin, here at EFIT. And in Bogota, you see our main professor on the bottom corner. You see Sylvia Constain, some of her colleagues, some of our colleagues there, and then a bunch of the participants there as well. Not pictured here are Cali and Barranquilla, which are also 2 of our sites. So, and this is Medellin, and you can see Spencer. Spencer's cut off, okay. Spencer's standing right here. So that's where we are. And I'm not going to go into detail about the actual class because Spencer's going to do that in a much more engaging way. I want to talk to you now about, you know, this concept of ecosystem, very much becoming a cliche in business. We think it's a real concept, and here's how we're building it. Number one is the speaker series that we showed a clip from. This is Alejandro Correa, but he's not the only speaker we've had. We've had speakers from Ecopetrol, from Rappi, from Amazon, from Calba, from the Colombian government, from all the really major employers. We've had our pick of some of the best. Students have been incredibly happy with these. Companies come to present and they say, not come work for me, but what is data science today looking like at my company? Very, very applicable things that are not simply for an employment. It's for training and thinking and dreaming about how can I use what I'm learning today in the job that I'm going to do tomorrow. So this is Alejandro talking about some of the skills that DS4A gives our participants. And then beyond that, the ecosystem also gives you connection with major people. In a small classroom setting, you can talk to someone like Sylvia Constain, who came, this is at AFEAT last weekend. She stayed for a few hours, talked to our participants. This to me is one of the big value adds of our program. You can talk with leaders throughout government, through industry, through academia, colleagues, peers, mixing with people in a way that you can't do through online-only education. Here she is, selfieing, group photos. And just to put a kind of quantitative edge to this, this is our online ecosystem that we talk about bringing here. So we have a Slack channel for the 300 participants to exchange messages on. They talk about whatever they like. At the opening class, they had sent about a couple hundred messages. This was a month ago. They had sent over 30,000. So if you do the math, that's 300 people. On average, someone is posting about 100 times in just a month. And the engagement is incredibly high. The vast majority of participants are engaging with each other on Slack weekly. And this is the community that we think is solidifying here in Colombia. So when you think about it, at this point, it's over 50,000 messages. It's everything from posting jobs. This is a participant in Bogota posting about a job in Bogota for data science, to these guys in Medellin celebrating a friend's birthday. You know, it's not just working, it's having fun together, becoming friends, grabbing drinks, grabbing lunch, all the things that you'd want to do in addition to just learning about data science. And the results have been really strong. So 97% of students have stayed in the class, as compared to about 5% on Harvard X and MIT X, which are other online courses. Homework completion is very high, 91%. It's compared to about 60 for other programs. And participants' satisfaction is very high as well. And we think this sets up, as I transition to hand off to Spencer, this is what we think about as Education 3.0. We don't think about this as displacing EFEAT, but supplementing it. EFEAT, other colleges. This is a type of education that's distributed, interactive, online and in person, and combines the best of in-person and online education. So here's a little bit about what I mean by that. The in-person elements are that you're talking with professors and teachers who are literally the best in the world. We have teachers, our main professor is the top teacher at Harvard University, Nitesh Pillai. He's a tenured statistics professor there. We have teaching assistants from Princeton, NYU, like Spencer, MIT, University of Waterloo in Canada. These are the absolute best of the best, and you're talking with them as friends, one-on-one. They're giving you incredible feedback. You're also meeting employers directly. You're talking with government leaders. You're working on group projects in person. That's something that you can't get through a computer. In addition, you have virtual elements like platforms and chat rooms and things where you can share information in a very efficient way that you can't just do if you're sitting in a class. And then finally, we're adding new elements like calibrating the curriculum to Colombia's employers and tying this to the ecosystem building mandate. So saying to Mintique, saying to our partners, we're not just here to educate people, but to create a community. So in summary, I just want to reiterate those 3 points. AI is the future. It's the driving force of tomorrow's economy. Talent underpins AI, specifically local talent. There is no way that only one country, one city, one population will do the AI for the world. Every single country needs its own AI infrastructure and AI ecosystem. And that's where we come in. Data Science for All helps to drive that. We think that we're building it today. And I'm going to pass this off to Spencer. Oh, one thing. This is my thank you. Don't know why it loaded like that. If you have any questions, email me. Happy to connect. And I'm going to pass off to Spencer now.
All right. Thank you, John. That was a wonderful presentation. So John talked mainly about Correlation 1 and DS4A in terms of ecosystem and what we're trying to plan for the local community here in Colombia and elsewhere. I'm going to talk a little bit more about the program in day-to-day class structure, as well as data science as a whole. So this will be my brief talk on DS4A and a data science lightning talk. Our agenda will be what is data science in general, the science of problem solving, how do we go through a workflow, because data science encompasses a lot of things, a lot of skills. So what's the workflow we follow and teach in the curriculum? I'm going to have a little thought experiment here for our astute audience to participate in. And then as that relates to the lessons and the case studies that we actually talk about in class. Finally, I'll talk about the final projects and show a few examples of those that the students are preparing right now. And I welcome everyone to come see next week here. All right, so first of all, what is data science? A lot of people, when you look up data science, have probably seen a variation of this Venn diagram. Data science is a cross-disciplinary skill or field, if you may, of math and statistics, so traditional research, engineering, and I would put data engineering into that category as well as subject matter expertise or business. So people that come from consulting or a particular industry will apply their subject matter expertise. People might come as a software engineer, and other people might come from a math or statistics background. One thing that I've come to learn from teaching hundreds of students now is you don't have to come with these backgrounds. Of course they help, but the most interesting projects are really where data science is all about. It's the combination of all of them put together. So we teach the skill sets of computer or engineering as well as data science, but really when you combine it with unique subject matter expertise, you get very interesting applied projects and endeavors. Another dimension I like to add here, and n-dimensional thought is really important, as we'll come to learn during my thought experiment coming up. So the ability to think in a higher order space. I like to add another circle going into this plane here, that's creativity or art. Because one thing that people don't talk about a lot is that coming up with a unique project requires creativity. You need to have creative solutions, and presentation is extremely important. So being able to present your findings to a stakeholder really depends on you knowing the audience and you knowing how to visualize or really drive whatever point you're trying to learn or express home to the audience entail. Cool. So that's data science as a whole here. But what about machine learning and AI and deep learning, all these buzzwords that people talk about? Data science encompasses all of it. So it is a field that has, like I mentioned, cross-disciplinary, but data science, as we'll talk about in the workflow, is not just the modeling part, but also data acquisition, data munging, how do we manipulate data that some people as analysts might be used to with in Excel, right? We take it a whole step further with modeling and doing it all in code. Artificial intelligence is the largest bubble. And artificial intelligence usually means mimicking human cognition. So these models, we are trying to mimic what people do naturally through engineering and through formulas. Machine learning is a subset. By the way, also, artificial intelligence, although it's the largest circle, usually is used by the media to describe whatever the cutting edge model is in the industry at the time. So that title is a little ambiguous in the fact that it does encompass the whole field, but when talked about colloquially, it usually means whatever the most advanced subject is. in this case, deep artificial networks. So machine learning being the subset of artificial intelligence is traditional modeling, right? This is learning parameters of an equation without them being explicitly set. So we have data, and then we have a goal we're trying to accomplish. And usually business analysts write their own formula given domain expertise. Machine learning sort of turns that on its head. It changes the paradigm by you still need to choose the correct formula or correct model, and we'll talk about what that means in a second, but we can learn the coefficients of the parameters by themselves. Deep learning takes that a step even further, where we don't just have input features, we have new features that are learned from these input data points that you as humans may or may not be able to interpret, right? How do we convert input image data into features like edges or eyes or noses, et cetera? It would be very difficult to have a data set that encompasses all of these. Deep learning learns features and then generates it for an output. So each one of these changes the paradigm. Cool. By the way, if you have any questions, this is more of a discussion, so please stop me at any point here. I don't know if we can get the virtual questions from the other locations, but anyone in this room, feel free to stop me. All right. So data science is important because it's really the science of problem solving using data, right? This is something called the data science workflow, which mimics what traditionally is known as the scientific workflow. If anyone comes from a STEM background, you should be very familiar with this. We do the same thing, but with data. So we usually develop a hypothesis and find data for it, or we have an interesting data set and come up with a project with an interesting hypothesis for it. And through that, we go through and obtain the necessary relevant data sources we need, clean in data to the expected format, because sometimes data is not, the term is often this data is very dirty, it's missing values, it's either unexpected inputs, and we have to manipulate it so that our models can know what to expect as the input and it can interpret it correctly. Next, we do exploratory data analysis, which is stuff like descriptive statistics, starting to plot scatter plots, starting to understand the latent structure of the clean data that we've imported here. This is a really important step because some of our previous assumptions when we created our first hypothesis might change as we start to explore the data itself. And through exploring the data, it can dictate what models you end up choosing to achieve the business requirements of that particular problems in a whole here. Second, or fifth step here, I guess, we construct models that can be determined from the exploratory data analysis, or we can brute force it and try a bunch of models for our achieving the metric we want, which, you know, depends on the case. Finally, how do we interpret these findings and then present them to the audience? This part relates exactly to that extra dimension in that Venn diagram, and a lot of emphasis is placed on this course on projects and applied data science, because you need to not only know the tools, but know how to encapsulate the important findings you generate from your project and then relate that to the audience at hand. The final part is, this is an iterative process. None of these, it's not sequential, and then you just go through and it always works out here. At any one of these stages, you can iterate, and you should, because say I understand from exploratory data analysis, I find missing values, I find things that were unexpected, I might need to go and collect more data. I might not get the results I want, and I need to try a new model, so on and so forth. So this is the overall workflow for problem solving with data science, and it relates directly to the curriculum that we teach at Correlation One. We have a 10-week program currently, and this 10-week program directly relates to each one of those steps. So first we teach the fundamentals of, people come here with a programming background, but fundamentals of Python and Pandas, which is how to manipulate and munge data. Then we go into EDA. How do we explore and generate graphs and start to do things of that nature. Finally, in about week 6, week 7, we start talking about traditional machine learning. Remember that bubble inside artificial intelligence. And those are where we know all the input features for our output. And then towards the end of the course, we start talking about deep learning and neural networks and these other terms that people may be familiar with. Finally, I'm going to talk extensively about projects at the end, but throughout the course, you don't just spend week 10 on projects. Throughout the course, we dedicate a lot of time towards actually applying what you've learned towards a final project in team. Any questions thus far? I want to save them all for the end here. Okay. So I'm going to take a little aside here. We don't have time to go through an entire lecture or case study, but I'm going to give a little foray as to the type of content we teach in this curriculum. So a quick thought experiment. Say this was our input data here. This could be X, whatever X we want, like weight of people in this room, and then Y we're trying to predict their height. There's some relationship between weight and height of data points that we collect. And what we're trying to really do through machine learning and data science is to create a decision boundary or something that helps us define that relationship, right? Helps us encapsulate the latent structure of the data in order to usually do prediction. Not always, but usually prediction. So if I were to draw a decision boundary here, and again, maybe there's this male and female as the blue and red. That's another thing that's a little abstracted away here. How would I, where do you think I would draw a line, or anyone? Yes. It's okay.
Hello. Okay.
Oh.
I think that we could divide into groups.
Sure.
These points, the red ones and the blue ones, and we could find like there's some behavior happening there if we draw a line in the middle of those two groups.
Yeah, I think it's pretty easy to visualize here that if I drew a line right through this, it separates the red and the blue, right? So maybe height and weight have a relationship with male and female, and those being those two colors. That's really what we're trying to do here, is we find a formula, and again, this is an example. In this case, it's a linear relationship, so we're drawing a linear plane to decide these two values, or to decide height or weight depending on what our Y is. But really what we're trying to do with any one of these machine learning models is decide how to best draw a decision boundary in an n-dimensional space. So having this type of thought or being able to think this way is really important. This is it on 2 dimensions, but imagine if I had 20 more columns. Height, weight, age, I don't know, etc. I'm only plotting 3 here, but you can begin to abstract at a higher order dimension. The same thing applies. With a linear relationship, I'm drawing a linear plane. Now, with this data set, it's pretty easy. It does a good job explaining the relationship between those two categories, but it's not always that simple, right? There might be a more complicated latent structure to our data. And this is why we learn so many different models. Each one takes a different approach, using a different formula, of trying to break up that latent data structure, right? A simple linear regression, in this case it's got a class as well, so it's a little bit confusing here, but we can draw a straight plane between these two classes, or draw a line directly this way, actually, with linear regression to mimic the correlation between X and Y, right? We can use a decision tree, and it's a little bit more boxy. We can start to use more complicated models, which we teach later in the course, to create a more unique approach at deciding that classification problem. And then some more advanced models as well. We pick a model that best matches the latent structure of the data and the business requirements. So what do I mean by business requirements, right? Don't we just want our model to always be the highest accuracy or whatever metric you choose? not always the case. I mean, if you're trying to achieve just accuracy, sure, we can throw the most complex model towards it and optimize for that. But, sure.
Maybe talk very briefly about why the 4 different like paradigms here look the way that they do, and maybe even how you would teach them. You don't need to go too deep, but I think it'd be really helpful.
Sure. So if we look back towards our linear regression here, actually this is a classification problem, so we probably use something like logistic. But if I'm trying to draw a line through an n-dimensional space, the underlying formula translates that relationship between our input variables or our features and our target. With any of the rest of these, the formula changes on how that decision boundary is actually drawn. Okay? So I can accomplish any line or any direct plane in that n-dimensional space using linear regression. But if I need to architect something that's a little bit more complex, I need to have a different formula to do so. There's a couple things abstracted away from this that we don't really have time to talk about. I might mention the next slide here, but decision tree is another simpler model. A random forest here, as you can see by its complex decision boundary, is an ensemble model combining others as well. But we do talk about these things in the course and how to build them. Everything, though, relates to what your business requirement is. So as I was saying before, if I just wanted to achieve the highest accuracy or the highest metric that I'm using, I might just choose a very complex model. That, however, we at all times want to have a trade-off between overfitting in our data and having our model also be interpretable. So I can choose a very complex model, but I still need to do a good job of making it fit on the training data, on the data we have available to us, as well as generalizing well to unseen data. What all this means is taking a complex boundary and softening it or smoothing it out so that it matches the fitting to the data we have on hand, as well as the true population's latent structure for new incoming data. Cool. Our goal is to overall minimize our error or maximize something like accuracy, but also a trade-off between model complexity, because as a model becomes more complex, we can't explain what the input variables actually mean. So something like linear regression, I could say for every 1 increase in X, an increase in weight relates to this increase in height, right? We know what the features are because it's a traditional machine learning model. If I start getting to a model that might have higher accuracy, like a deep learning neural net, I might not know what the features actually are. I might not know what those coefficients are for the internal nodes. So it becomes a lot harder to explain to a business stakeholder. The point is that there's this constant trade-off, and we talk theoretically about these machine learning concepts, but what we really try and hammer home is having the consciousness to make those choices, not just trying to throw a new tool at this particular problem to achieve the highest accuracy. We don't want to just teach you tools for the sake of achieving accuracy. We want you to understand the choices made in model selection, in cleaning the data the way you do, et cetera. So that was more of a theoretical thought experiment. And that might be more traditional that might be more akin towards traditional education, right? Correlation 1, and I've touted a few locations here, does a very unique job of doing case studies. So we don't just go through every concept one by one and explain it. We actually apply it to a particular business use case. This is really important because when you go towards using data science in the real world, you can remember back towards the case studies you learn in this program and say, oh, that was just like this case. Maybe I should apply some of the same techniques. So some example cases we have is, early on in the course, there's one that's how do users engage with mobile apps for automobiles. And through that case, we teach why data visualization is so important. Later, there's a lecture on classifying images of Colombian celebrities, picking one versus the other just using the images. This is a really good case study for explaining how to use convolutional neural networks. So we don't just teach the concepts in isolation, we actually apply them to a business use case, which will help you in your jobs, as well as help you associate it in your mind for future projects and for your final project. Okay. The general schedule for DS4A is every day is broken into, we have 2 applied case studies, like the ones I mentioned above. And these progress sequentially in the curriculum as well as in the workflow that we saw in the earlier slides. So we start to build upon the tools you learned previously towards ultimately working towards a group project. Now this group final project we devote, and this is subject to change, but we devote every afternoon towards working on this project with your team and applying the information you've learned from the cases earlier in the day. Most of our work is done in, or case study work is done in Jupyter Notebooks, and we may open source this material for, we're going to open source all this material for everyone to use, so you're welcome to go look at the notebooks that we actually teach our students coming soon. So in our day, we talked about case studies. We talked about how that's a unique way of learning as opposed to a traditional education, and applying the theoretical concepts to an actual business use case. But what we're really trying to work towards is you applying it to your own project. As you can see, we devote a lot of time to group project time every day. So let's talk about, in general, what makes a valuable data science project. Usually, it's good data and good impact, right? We need good data and clean data. Otherwise, we can't really have a good project. And what makes a good project, in general, it's where it has an impact for the audience at hand. So I use this with students sort of week 1 to help them come up with projects that have value. And this is completely subjective. So you can tailor this to be entirely related to the audience you have. This might change entirely if you are working for a company. But in general, for our students, we're trying to have ones that have economic, social, political, et cetera, impact for Colombia as a whole. So you want to have good data where it's got availability, it's easy to access, whether it be scraping, CSVs, et cetera, how difficult it is to access, whether it exists at all, how complete it is, and then its impact here economically, socially, politically. You can add your own columns, but we teach the concept of scoping a project in addition to just the tools necessary to build that project. There's a middle column here called interest, which is the interest of the students themselves in that particular project. Building a dog emotion classifier is really cool, but it doesn't really have a lot of impact on the rest of the world. So we might try and focus, at least for DS4A, on the impact of the project beyond just your group. And then, of course, value is a way of quantifying that. So with students, we fill out these numbers and give it scores that change or iterate through the workflow when you're developing the project itself. Cool. Another thing when it comes to project scoping, I always tell students that we should focus on projects that mimic more of a staircase. This is an image of a staircase that exists, I believe in France, carved into a cliff. And of course, I wouldn't want to scale this cliff and have the whole project be hinging on the fact that one thing needs to work, where I'm very susceptible to, if one thing fails, the whole thing fails and I plummet to my death here, hypothetically. What we'd want to have is a project that has a stepwise objective nature to it. So let's first build a model that predicts the initial target. Then let's build an initial dashboard here that helps perform EDA. Maybe I have, as a later step, pulling in data automatically, so I generated real-time predictions. You want to have a project that mimics the stepwise goals, as opposed to everything being hinged on one data source working, one particular element of your project being essential to its overall success. Some of our fellows' projects, because the proof is in the projects here, and I spend a lot of time focusing with students on this. As you saw from our schedule, almost half of our time is devoted towards group projects. I'm going to run through 3 example ones here. One group has made a career recommendation system for high school students based on similar student performance. And this is going to be used for government officials and university execs to check performance across regions, across schools, to help better suggest to students what degrees they should potentially pursue given their skill set. And we really emphasize building something that can be visualized, because you can have a model that is extremely accurate, but remember, the stakeholders or the presentation or how the art of presenting a project is almost as important as the actual work that it entails. If your audience doesn't understand the point you're trying to drive home, then the work itself is not as valuable. Another example project is another group has taken real-time surveillance pictures of intersections within, I believe, just Medellin, I'm not sure. And they've built a traffic prediction software where they're predicting the flow of traffic as it goes to try and predict when to send cops to a particular intersection, help inform the government on areas where there's a lot of congestion to maybe improve the infrastructure itself. Finally, this is the last project where there's a dashboard where they have a data set of trucks and transportation data throughout Colombia. So they're monitoring transportation of goods from cities to cities in hopes to help optimize supply and demand of available vehicles in each location, as well as predict where to open hotels or rest stops, if that thing, for people currently stopping. So each one of these projects has multiple scopes to it, and that's what makes them valuable. They all have a direct impact on Colombia, and they've all been accomplished in this short amount of time. Lastly, I want to say, I sort of alluded to this before, but data scientists sometimes are more librarians or artists than just mathematicians. I think this is really true because we don't want to teach just pandas, just scikit-learn, just the tools necessary at this current time to manipulate data, because these constantly change. It's an ever-changing field. It's a new field. We really emphasize that the ability to learn and research documentation on your own, be autonomous in your own group structure, skepticism of data and data sources or even packages that you're using is a really important skill, and ingenuity in combining the tools we have to create unique projects or solutions that may not be what is traditionally taught, with each one of these subjects. So overall, I'm thoroughly impressed with the skill set of the students we have. The projects are truly amazing. I have added my contact information to this last slide here. Sorry that it's in blue, it should be in white. We're going to send out contact information. You're welcome to reach out to John or I with any further questions you have. John, of course, can talk more about the ecosystem. If you want to learn more about the curriculum and day-to-day structure of the program, feel free to reach out to me. Great. Thank you very much for your time. Yeah, any questions from the audience here?
Hello. Are
mic
you
is-
going to open any course on 2020 in Medellin?
I think I'll give this question to John.
It's a good question. What was your name?
Daniel.
Danielle. Good question. We're right now figuring out how we're going to expand. We really, like we showed, I think the demand is there, and I think Mintique wants to expand. We're still finalizing details, but there are several different ways that we can do it, but long story short, I think we will. So if you want to follow Correlation One on LinkedIn or email me, I can send you more information. And that goes for any of you guys. All of you are front of the line if you're interested in applying or in participating, in having your companies participate. Let me know.
And what are the basic knowledge that we have to know in order to get into the course?
Yeah, it's a really good question. We're still scoping it out. For this version, we really wanted to take people based on merit. So high performance in our technical exam was the kind of main component of what got someone into the course. But in addition to that, your resume or your CV, where you went to school, and then some other information about, do you know Python, do you know SQL, what technical skill sets do you understand? That can help you get in. But that being said, you don't have to know everything. We don't expect everyone to know everything. And in further iterations of this course, it will likely be accessible to even people who know nothing, or people who know a little bit, or people who are business managers and don't know AI or data science, but want to learn. So the expansion is going to be not just in terms of number of people, but also types of programs we think. So stay tuned. Are you a EFE student or?
Yeah. I study mathematical engineering.
Okay. Yeah, perfect. That's you should be fine. And this program was just for professionals, we should note, but further programs will be for students. So this program is only people who have finished school, but next versions will have students and others. So, yeah.
Do you have any allies when it comes to taking these projects and taking them to the real world? For example, when you finish all the course and these projects you're having, what do you expect? Like if you have a project in health terms, or if you are working with transportation, or those projects that you showed, what allies do you have, or what do you expect to do with them?
So generally the people that are in this course are already employed, right? So they're already working in a particular firm. And you're not required, but a lot of them have adopted choosing data sets related to their industry on hand. So with the idea of going back to their company, proving it was worth giving the time to come to this program, showcasing the skills they've learned. For those who, with later iterations, we might be accepting that are not actually working professionals but seeking a job, I always advise people to, although data science is across industries as a skill, of course it makes sense to choose a project related to the industry you hope to get into, because the person that's viewing it may not understand the underlying models or some of the lower level components, but of course they can see your presentation and see the merit in that as it relates to their field. So it's a varying project. I mean,
Hey, okay. The other question is for you about how much mathematical foundations you teach at this course about the models, because sometimes they teach a lot like, oh, it makes this like very surface, very shallow, and I'm really interested in what the mathematical foundation is. So how much of this part is taught in this course?
The initial, this one is much louder. I should have had this mic the whole time. All right. How much do we actually get into the underlying math, right? I believe that this program, John can speak to this too, is we have people of varying backgrounds, so we try to teach what is most necessary for you to apply the data science directly. That being said, I know a lot of other courses out there that'll teach you a tool set and then you follow the same workflow for some end goal. You know, throughout, we do teach you the tools necessary towards, you know, applying them directly and quickly, but throughout that we try and focus on what's the effect of changing tuner parameters, what's the effect of changing your data this way, so on and so forth. So I wouldn't say it's akin to a PhD program where we're going to spend, you know, an entire 6 months on one particular subset of models perhaps, but we do our best to, for the students very interested, taking the time to, after initial lectures, go through and explain the underlying math if they so choose to want more of it.
I want to also talk just a little bit about the application question that you asked first, because I think it's a very important question. And it gets to this issue of what's the point of all this? Like, if you are coming up with the greatest idea in the world and you can't communicate it or send it through an institution like a company or government, something to really change the world, your idea is not worth anything. So student projects, they're finishing right now. Next Wednesday, you're all welcome to come to AFE to watch the presentations. They're going to be really interesting. Business leaders will be there, and then afterwards there's a career fair on the 11th for participants to talk with major Colombian companies like Da Vivienda, Banco Bogota, Ecopetrol, Rappi. Their representatives will be on site to watch the presentations, learn about them, hear what people are doing. Startups will be there, small Colombian companies with 1 person, 5 people, who are looking for innovation in healthcare, transportation, arts and entertainment, social media, everything. And then the winning projects, so we're going to select 10 of the best projects that will then present to leaders from President Duque's government, from Mintic, from major Colombian companies and major international companies that can then potentially partner with participants to take those ideas and make them real. So there's a structure here to not just make the project and then it disappears, floats away, but becomes something important for the world. So, and then in next versions of the class, we're hoping this is going to be way bigger. More companies, more resources, more people to collaborate with. This is just our first time, so we're still learning and we're still building. So that's it.
Is this the only mic? Does that work? Mic work?
Well, before of going to the question online, I want to ask you, how do you think that an enterprise that never had experience with data science, I mean, that have been only manipulating stuff like business intelligence or data analytics, could build an artificial data science ecosystems in it?
So I think, although this is more of a John question, I think we're really cultivating the ecosystem here, right? A lot of the people that I've spoken with, a lot of our students here, come from companies that have done part of the workflow for my initial slides, right? They've gone and done EDA and some traditional, some simpler models here. But these people we teach are going to take the skills we've learned, go back to their companies, and be the pioneers of progressing some of these more advanced modeling techniques, some of these newer data science concepts that we teach in the course. So that's the exact reason why we're here, is to try and cultivate that ecosystem and develop the skill set in the people that already have some foundation, but expand on it even further.
Okay, thank you. I'm going to read all like questions.
Sure.
Luis Abdul asks, in the future, data science, it's going to be optimized, even for professionals that are not going to be needed?
Can you say that again?
I mean, are going to professionals be replaced by this data science topic?
This is a question that comes up. Are we going to automate our own jobs? And we're not going to spend the time to talk about general artificial intelligence right now, but there's always going to be a need for people to drive the cars, right? No matter how complex the car gets right now, we still need an engineer to understand whether it transitions from mechanical to software to maybe something else. We still need people to understand how to drive these systems. So although the paradigm changes, you still need experts in the field.
My question is about the future. Is in relation to the other technologies, for example, about the other technologies in relation to the data science. For example, what is the develops near in the data science?
What is the last part?
Like future developments in data science, right? Maybe like repeat the question.
So you're asking what are future developments in data science in general? So, I mean, it's such an iterative field. So deep learning has only become really popular in the past maybe less than 10 years with the advent of more data being available for these models. And so because of that, the ecosystem behind teaching it has has followed. So based upon the data we have and the tools, they're really starting to change what is taught in this particular course. And we're keeping on top of what is the most advanced in the industry at the moment. So I don't know what's going to be in 3 years, 5 years from now, but so far this course does its best of talking more about the concepts that are important, not an individual like package or software application that you may or may not use for solving a data science problem.
Yeah, and I think it's a really important question, Francisco. I want to, Spencer can talk more about what the horizons are, like where is all of this going. I'll say this about our methodology and why I think it's superior to how other programs are being built. We have a group of data science experts from the top institutions around the world developing our curriculum really almost as the students are learning it. In some cases, the cases that students learn are built and finalized a week or 2 weeks before students learn them. So literally this field that's growing so fast, you're getting the knowledge of the world's experts delivered by the world's experts the week before, a day before. It's so current because the methodology and the thinking behind it is if you're teaching someone skills that are 6 months old or a year old, and then they go to a job and they apply it a year later, by that time it's already an antique. It's far too old, and it can be almost counterproductive if your learning is that far behind. It's critical to be on this cutting edge and be tracking it as it moves for big changes, paradigm shifts, as Spencer's been talking about, or even small ones. Incorporate both. So.
Yeah, I think to John's point, because of the nature of the participants or the nature of the people working on this project, we have the ability to iterate a lot faster than maybe your question earlier about a traditional education system where you're going to talk more about fundamental concepts and go deep into the math. We have spent the time to iterate. So next group with more students, we're indefinitely going to have new cases, but there may be entirely new topics as well.
Okay, is that it, Francisco? Okay, thank you again, guys, for coming, and please, this is, yeah, we'll email you, but it's Spencer@correlation-1.com, and I'm John@correlation1.com. Yeah, somewhere here. Okay, write it down if you need it. I want to hear from you guys. So thank you again, and hope to see you soon. Thanks.